on this computer, boom. Okay, so smile everybody, you're now being recorded. And if your camera's muted, then I guess smiling won't really make a difference. Okay, so compare to. So all things that can be compared and sorted are a subset of the class comparable. So if we go to Java interface comparable, right? All things that are comparable, they extend this interface. Anything that can be sorted, and no all known implementing class. Here's your date, here's your error, Japanese date, local date, tray icon year, integer should be, so big integer. What's a big integer, by the way? Anybody know? Anyone know what a big integer is?
It's like an integer class that avoids an integer overflow.
Exactly, right? All integers, right? We have the issue with in Java of having integer overflow, where basically if we try to add integers and we get something above 2 billion, then it decides to overrun, and then you get Gandhi nuking everything. I'm not joking. That's an actual thing. In Civilization 2, there was an error. Well, that was an underflow. But what they did is that basically Gandhi had as the leader of the Indian civilization, had an aggressiveness of 0, and then these were unsigned integers, so they wouldn't go or these were unsigned bytes, so they wouldn't go negative. And so once you got to the modern era, a bunch of AIs would adopt, like Gandhi would adopt democracy, because that makes sense, right? That's more peaceful than, say, monarchy. So that had an internal modifier of subtract 1 from the aggressiveness. So that caused an underflow error, which made it wrap around to 255. And so suddenly in Civilization 2, once you hit the modern error, Gandhi had, well, this was the result. Our words are backed. Right? So you'd get stuff like this.
Hey, sorry to interrupt, but could you try to check the group chat every once in a while? Because there have been a couple questions.
Oh, really? I thought I was getting notifications, but thank you. Excellent questions. So sorry about not seeing the group chat. Again, I've not really had to do large lectures like this. So also, will quizzes be posted? Will they have to be taken on time? There will be quizzes posted. I'm going to start posting them actually after this lecture. They will not have to be taken on time. They are by taken on time. Well, kinda. You'll have an explicit due date, and you'll have multiple attempts on them. Okay, so they will be done. So they're like have it done by the end of the week kind of deals. You know, just rather than like making sure that it's like, are you showing up to class and reading the material? This is, are you just keeping up with the material kind of deal. So will they be open for a longer window? That is the case. They will be. So like I'll post something here and it will be due Friday, and it will be a normal length quiz, like 10 minutes. And the reason why I'm doing multiple attempts is because it's quite possible that, look, you did not sign up for an online class, and an online class assumes that you have constant access to the internet. You do not necessarily, I cannot assume that you have constant access to the internet or a stable internet connection. So multiple attempts are a reason. Is this lecture going to be recorded? This part is, where I said I was going to start recording. So going back to big integers, right? A big integer is comparable. A big integer is comparable. So that means we can sort them. Now, how do you compare things using comparable? You use the compare to method. So let's see. Do I have? Let's see. So, all right. Properties. That should be nice and big. So let's take a look at an example of this. So hopefully, what is it called? JShell. Should have JShell. Nice. Okay, great. That means I can kind of show you guys how this works. So integer x is equal to, actually, let's do with strings. String word1 is equal to apple. String word2 is equal to aardvark. And basically, this is just like a Python REPL. Basically, I'm just executing line by line, okay? And then to compare two comparable things like strings or integers, you say thing1 dot compare to, and I always forget, is it compare to or compare to? It is compare to with a capital letter. So we got 15. So that doesn't really tell you much, right? Unless you know how to read it. Compare to will give you basically 3 broad categories. It will give you, if I say word1 compared to word1, we get a 0. If you get 0 with a compare to, that means the two things are equal. If you say compare, and I believe I went over this in my video lectures, but if I say compare to word1 dot compare to word2, we get a positive integer. This means that word1 is bigger than word2. Wait, how is one string bigger than another? How is apple bigger than aardvark? Aardvark is certainly a longer word, right? Well, by here, we mean it's big. Bigger isn't necessarily the thing. It's a terrible word to use, but simply put, it comes higher up if I were to sort these things. Aardvark alphabetically comes before apple. AA comes before AP. So alphabetically, it comes after. And so if you get a positive integer, you know this will come after it. Now the 15 is internally telling it like what the difference is when we're sorting alphabetically. I'm sure. I mean, I have a feeling that A minus P gives us 15. So that's why we'll get there. And then if similarly, if I were to do word2 dot compare to word1, whoops. Word2 got compared to word1, we get negative 15. We get a negative thing, which means that this, if it's negative, it's smaller or comes before. Positive means bigger or comes after, depending on what kind of comparison makes more sense. But basically, anything that can be sorted is comparable in Java, and that means it will use the compare to, right? And here's the documentation as well, right? Oh, and by the way, you can also note it's a transitive thing. So that's pretty, so it follows transitive operations. Oh, and it is strongly recommended, but not strictly required that if they have equal values, then they equal each other. But it's honestly best if you do that. So anyway, so we can use the comparables there in this index tree. So root dot, so what you'll typically want to do is, remember, since you're comparing the words in them, what you're actually going to want to do is something like this. Int result is equal to root dot word dot, or actually word dot compare to root dot word. So you want to use this as the result and then check if the result is 0, a negative number, or a positive number, and then you know which case you need to do. The contains and delete, by the way, should be the same as in the book or as in the lectures, pretty much. Notice that they don't use the line number. So really the big thing over here is this. And then print index is the other big one. So you're going to want to create a, you might want to create a recursive method for that one as well. Okay. any questions about this one specifically? Otherwise, I'm going to see how otherwise I'm going to check out to see how we can get breakout rooms working, because I've never had the chance to test it with so many people, which is really what I wanted to do. And then once we're in breakout rooms, I'll be able to start demoing you can start screen sharing with me and start demoing. And the reason why I can't just have you screen share here is that if you were screen sharing, you'd be screen sharing to everybody else, which kind of doesn't necessarily make sense. So, okay. Any questions before we move on? Speak now, forever hold your peace. All right. Stop share. So let's go ahead and see what we can do for this. So manage participants. So more, let's see. So let's see, breakout rooms. So let's go ahead and create 12 rooms. See how that works? Create rooms and then options. Allow participants to breakout rooms, close after, okay. Countdown after closing breakdown rooms. Open all rooms. So let's see. So are you guys able to join those rooms if you click breakout room on the bottom?
I don't see anything that says breakout room on the bottom.
Okay. All right, so let's see. Let me take a look at that. I should probably have checked that out beforehand, but so I thought that would work better than 50 separate sessions, enabling breakout rooms. Recorded only will record the main room, so that's good to know. You can choose, the host can split and can manually switch sessions anytime. So prerequisites. So account settings. Okay. Pre-assign. Enable breakout management. Sign into Zoom Win portal. Account settings. All right. So what I can do is I can move all you guys into them automatically. But that would get you, but you wouldn't be working with with the people you normally get to work with, which is tricky. Oh, room system. Nope. That is frustrating. That is frustrating. Why don't we? All right. So let's just go ahead and, all right. Let's get automatically 2 people per room, recreate all rooms. Boom. There we go. Hey. All right. I'll be jumping into the rooms and basically demoing a couple of people at a time. Everybody okay with that? And then you can work with the person who's with you and ask them questions. Sound good to everybody?
Mm-hmm.
Sure. How do we know which breakout room we're in?
You are about to find out.
Cool.
Okay, you've been all invited to join your breakout room. So hey there. All right. Hey there. Do you have anything to demo for me today?